Welcome back to this lesson. So in this lesson, we'll continue with part 2 of domain 3, deploy AI power business solutions. Okay, and what we are looking at is that's operating agentic AI solution, that's monitoring, analyzing, tuning, and optimizing. That's architecting, monitoring, analyzing, tuning, and optimization. Architecting validation, that's using testing prompts, model dynamic 365 end-to-end, and then governance, using application lifecycle management, security, risk, and compliance. So let's look at the next slide. So on this slide, we have diagnostic. Okay, so diagnostic is, monitoring the system and determining how it is doing, what it has done, or what is happening in the system. So that you diagnose whether diagnose if there is a bad feedback. You diagnose, that's root cause analysis, to determine what causes the feedback. So diagnosing application enable you to know what happened, enable you to investigate the system, observe the system, determine what has happened, why it happened, and what you can do to fix the problem or the error that has happened. So that's the purpose of diagnostic. And you can use diagnostic log. That's the purpose of collecting logs using Azure Monitor or application inside, and analyzing using KQL on log analytic workspace on Azure, or analyze basically using Microsoft 365 Analytic Center, or Power Platform Center, or Copilot Analytic Studio, and so on and so forth. So we have AI-based diagnosis and tuning layers. So we are going to look at the tuning layers and the tuning purpose. So these are the domain, okay, for diagnostic log, and these are the reason why you need them. So these are the issue domain. Okay, I mean, we have said that diagnosis is error or issue in the system. Then you diagnose to know the issue, to know the error. You test, you observe and monitor to know issue and error in the system, and then correcting the error. That is tuning the response, correcting the error. So the first domain we have is operational. So in operational domain, or your tuning response to all the errors that we have looked at should be fixed errors. So in operational domain, you fix errors, you increase or optimize latency, you stop throttling. If throttling is when the agent is working and stopping, or skipping, or failing at some point and working at some point, that's throttling. Then tune the retries. How many times does it retry? So that it will not continue looping on what it cannot do. And then also tune connector failures. So these are areas that you can tune or that you can improve based on feedback from that you have gotten. So this is operational domain, and these are your tune response. What you should look to improve or optimize in system. Remember, this is like optimization. We are discussing optimization here. Okay. So quality. So for quality domain, look at correcting issue like so your correction response or your redeployment or redevelopment response should be reduce incorrect answer, reduce hallucination rate, reduce weak reasoning, and reduce irrelevance output. Okay, so this tuning all this will improve the quality of the agent. Then for knowledge domain, so how should you tune knowledge domain? You can add missing content. Okay, if you need to add missing document, from SharePoint, from OneDrive, from OneLake, wherever they are. If the data semantic index are not properly indexed, then the engineer should properly index them and make sure they contain the right context. Then remove stale data. We have said several times that you are designing a RAG database. Do not use historical data that are no longer applicable to the context of the business solution. Okay, so do not use stale data. So remove stale data, improve structure and metadata. So improve the knowledge database, improve the RAG database, and also improve the metadata. So these are your tuning response for knowledge base, for database, which is applicable to Dataverse, SharePoint, OneLake, or RAG database. Then user experience. So how can you tune user experience? So your tuning response here should be reduce confusion. So agents should not cause confusion. Agents should not be doing tasks that they are not supposed to do. Agents should not operate within outside their boundary. Agents should not operate outside their context. Context is business memory or business state or business data, business language and information is what we call context. So agents should not confuse context, should not confuse business information or language. Okay. So reduce confusion, simplify flows, improve fallbacks and guidance. So fallback is what the agent can fall back to after it has failed to implement a particular action. If it has called a tool and the tool fails, if it has checked the drag database and there is no knowledge to use, what can it fall back to perform the task? That is called fallback. So you can improve the fallback. If there is no knowledge in the database, is there a tool to call to perform the task? If there is no tool to call, is there a skill in the prompt that you can use to perform the task? So fallback is very, very important. You should also improve it and also improve guidance. For governance, so governance has to do with monitoring agent compliance, setting guardrails, and checking whether the agent is operating within business logic, business rules, business boundary, and using business context. So for governance, look at improving review the data loss prevention lifecycle in Microsoft Power Platform. So this has to do with Dataverse, which are connected to Office 3, Dynamic 365 and Power Platform application. Then look at improving sensitivity labels. Okay, so check the guardrails. So our PII information redacted, our information that are not supposed to be exposed, gathered from the agent, and so on and so forth. So also look at tuning permission. Do not give agent permission to what they should not access. So look at permission. Check whether role-based access control is properly implemented. Check whether least privilege is properly implemented. Then check policy conflicts. So deploying on Azure, apply Azure policy. Deploying on Office 365 or connecting to database, make sure you apply company policy. So also check and tune response and usage of company policy. Then performance. So in performance domain, what you should look at tuning are optimize connectors. Okay, so make sure do not use wrong connector. Always optimize the connector, Power Platform connector or tool connector, or database connector, resource connector, Microsoft Graph connector, and so on and so forth. Always optimize the connectors, reduce workflow complexity. Okay, do not make the workflow complex. Do not combine several actions for one agent to perform. Break action into tasks and assign tasks to particular agents. So reduce workflow complexity. Okay, we have said that if action is simple, designed for simplicity. If action is complex, designed for complexity. The fact that you are designing for complexity does not mean that you should take a complex operation of an entire department and give it to one agent to do. It will not be successful. So break a complex workflow into sections, either sequentially or concurrently, then break them into tasks and design specific. If you need to design multi-agent system, design multi-agent system so that you can assign individual agent to a particular task. And when those tasks come up, then you know that this task 001 is always meant for agent 001 to perform. So reduce workflow complexity by using multi-agent system and deep reasoning where it's applied. Then improve payload size as well. Very, very important. If you are using if you are designing for a complex workflow, use LLM. If you are designing for a simple workflow, use SLM. So that's it. This is how you can, all this should be your tuning response to all these operational to all these domain issues and domain problems. All right, so the next thing we have here is performance. So performance is the, how your agent is performing, the usage. You have usage performance, you have, architecture performance, output performance. How is the agent faring in the entire business process? How is it? What are the metrics that you are getting Are they good or bad? So that is your performance, how the agent is performing, how the architecture is performing particularly. So to determine this, we will be looking at metrics, quality, and drifts. And the architecture terms you should understand here is latency. So latency is the speed between when the agent receives tasks and when it performs the task. When you give the agent a task to do, and when it generates the output is the latency. How long does it take? So that's latency. So is it high or is it low? Then so you should keep latency very low. The speed of the agent should be very, very fast. Latency should not be high. Then throughput. So throughput is a successful operation. So what is the success rate? How does it at what rate does it generate outputs, or does it perform a task? So success rate tell you throughput, part of the architecture. You have token usage, so LLM token usage. How many token is it using to perform a task? Is it generating high token for a simple task that should not be using too much token for? So token usage is also part of your performance, because you are optimizing you are generating business value. So and part of what you are optimizing is cost. You should minimize cost and optimize profits. So token usage should be very minimal, and the knowledge coverage. So does he have access to entire data knowledge that you need to perform the application? Does he have access to the right tool, access to the right knowledge, right database? And drifting. So this is a change in the output of the agent based on what it has, based on the knowledge base. So drifting is deviating from what the agent should give out, deviating from correctness to incorrect answer. So changing is also part of the architecture terms. So these are very, very important performance architecture terms that you should understand and have in mind. So metric, quality, and drift are the two things we want to look at here. First thing, operational metric that you should look at to measure performance include latency, throughput, error rate, resource usage, token consumption, and cost. Very, very important. So these are the metrics that you can use to determine, these are the metrics for determining performance of the entire agentic AI architecture. Then we have discussed the meaning of this under our, architecture terms. So as an architect, you should also have the knowledge of site reliability engineering. So these are particularly the function of site reliability engineer. They are the one that measure and oversee performance and reliability of the application and the architecture. But as an architect, you are a jack of all trades, and you know the in and out of the system that you are designing. So all these metrics you should also understand, so that you'll be able to measure the performance of your of the system that you have architected. Then quality metrics. So to determine quality, that is quality of the output, how accurate is the output, how relevant is the output to the business process, business information, and workflow. So quality metric that will help you to measure this include accuracy, knowledge coverage, action success, relevance, and groundedness. Okay, so groundedness, we are using your knowledge coverage to do that. Accuracy, knowledge coverage, everything still depends on knowledge coverage here. Okay. Then user metric. So what are the metric that you can use to determine the user success rates? How do you measure whether it is missing the agent that you have designed is meeting the user's need, is meeting the business owner's need, is reducing their time of work? Are they satisfied or not satisfied? So user metrics that you can collect and use here to determine the performance of your application at the user end are satisfaction. So collect satisfaction. How satisfied are they using the application? Abandonment. Do they abandon it because it is not meeting their use case, or it is not useful for their workflow? Completion rate. So how does the agent complete any task it starts? So also measure completion rate. Then ratings. So how high is it being rated? You've used in your software design, you will have put rating to measure user satisfaction in your Microsoft form, and the rating, are they rating the agent high, or are they the rating you get, are they very low? Then entire feedback. So you can also use survey to get feedback, like SurveyMonkey or Microsoft Form, to get feedback from the user and the business owner. So from the feedback, you can determine whether it is actually performing or not. Then we have drift sign. So drift is, when the agent deviates from generating accurate output, deviate from performing the task it's supposed to perform, or start hallucinating. That's drifting. So to measure drifts, so for drift sign, these are how you can determine whether the agent is drifting, whether there is a change or deviation from the correctness and accuracy of the output of the agent. So the signs that you should obtained from your monitoring tools are accuracy decline rate, hallucination increase rate, behavior changes rate, latency increase rate, higher retries rate, and connector issues. So all this will help you determine the performance of the agentic AI systems. Now, telemetry interpretation. So telemetry are log and the metric that you have collected using Azure Monitor or application insight, or using any of the platforms that we have discussed, like Power Platform Admin Center, or Microsoft 365 Analytics Center, or Copilot Studio Analytic or Insight. So when you collect these logs and metrics, they are telemetry data. So telemetry-driven optimization workflow. So how do you interpret the telemetry? So this is the pipeline for, building telemetry. So telemetry is part of the architecture, and then you also have a design for it. So it's part of what you are designing from beginning in your architecture design. So it is part of, it is also one of the foundation of the design. So, and this is optimization workflow of telemetric interpretation. The first thing we have is monitor metric. You use the platform that we have discussed, the tools that we have discussed, to collect metrics. Okay, so you monitor the metric and collect them. You are not just monitoring, you are also collecting them and storing them, maybe in blob storage, in Microsoft Dataverse, or SharePoint, or wherever you want to store them. Collect the log and the metric, then identify. From the metric, you analyze, either using log analytics, or you analyze using Power BI, you analyze using KQL, you analyze with the tools that are available that we have discussed, to identify and determine anomalies. Anomalies are, errors that are in the system, errors that can cause risk, errors that can cause application downtime, error that can cause the agent to generate inaccurate or incorrect solution or output. So identify the anomalies and then create signals. When you identify anomalies, you create signals. You don't just identify the anomalies and keep it. No, create signals. So signals will enable you to raise alarm that this is what is happening in the system, and the application needs to be, tuned and corrected to perform better. So so when you identify anomalies, correlate signals. So trace anomalies to the root cause. So correlation signal is tracing the anomalies to the root cause. So conduct root cause analysis, determine the cause of the anomalies. That's correlate signals. And then we have find root cause after correlating signals. So correlating signal is simply tracing, using trace. We have what we call tracing URI, or trace a part of the log that you are collecting anyway. So correlation will enable you to trace the anomaly to what causes the anomaly. So is it a tool? Is it a connector? Is it the data? Is it the model? Is it the prompt? Or is it anything in the system that caused the anomaly? So trace the anomaly to the cause of the anomaly, to the root cause, to the signal, to where the anomaly comes from, whether it is from the agent or from the model or from the tool or from any of the, any part of the architecture. So when you correlate anomaly, then you find root cause. So now you've correlated anomaly, you've traced anomaly to a particular part of the architecture that causes the problem or that causes the anomaly. Then you find the root cause. Now you go in depth to the tool or to part of the system that caused the anomaly and determine what makes it to cause the anomaly, why this error or why this failure in the system. So if it is tool, you check the tool. If it is prompt, you check the prompt. If it is LLM or base model, you check the base model, whether you are using the wrong model. If it is RAG database, then you need to check the database, or whether you are using stale data or historical data that is no longer relevant. Then if it is any of the Microsoft Graph, you check. If it is connector, you check. If it is deployment platform, you also check. So find the root cause, very important. Then after finding the root cause, you apply tuning. Now you've correlated and you know the root cause. You know the tool, what is causing the system. You know whether it is prompt, for instance. Then you apply tuning. The next thing is to correct what is causing the error, correct what is causing the problem. Okay, and then after that, you validate and redeploy. And then this is the whole process of optimization. You can see it's simple and it's followed sequentially. So you cannot start applying tuning when you don't know what causes the anomaly. Okay, so and then you cannot start identify anomaly after you have collected metric and just validate. So you don't just collect metric and go straight to validation. No, you follow the process sequentially. So this will enable you to get to the in-depth of what is called causing the anomalies, and then thereby you correct, and then you have a grounded design, a grounded agent, and then a reliable. Then doing this will help you build a reliable and performing agentic AI system. So interpreting high latency as connector or workflow delay, I token as a verbose prompt. So this is what you should do: interpret high latency as connector or workflow delay. Okay, so high latency should be interpreted as connector or workflow delay, because when agent calls a connector and connector didn't respond, then there will be delay. When a particular workflow fail, there will be delay. Okay, so interpret high latency as workflow delay. We have said that for a performance system, latency should be very, very low. Okay, so I interpret high token usage as verbose prompts. Okay, so that is why we say we should make your prompt simple and straightforward, and make sure they are contextual. Okay, so do not go just and break prompt into sections, break them into chunks. So that's why we discuss type of prompt. We have zero shots. So that's giving instruction. We have role based, giving the agent a role. We have a few shots, that is giving instruction with example, chain of thought. So that is breaking the prompt into sequence. Okay, and chaining them together, and so on and so forth. So high token use as verbose prompt, interpret error spikes as dependency failure. Okay, so if there's an error, that means task dependency has failed. So if there's an error in task 2, then you know whether task 1 has failed. And then interpret quality drop as drift or knowledge gaps. So these are how you read meaning into all this. So in order to use the telemetry optimization workflow. So enterprise KPI include responsiveness, accuracy, reliability, cost efficiency, task completion outcomes. So these are the KPIs or the return on investment that you're actually generating here. And then, of course, you are working with CEOs, you are working with CTOs, CFOs, business managers. So, and they are expected to see this KPI on your dashboard. Okay, so responsiveness should be very high, accuracy should be very high, reliability metric very high, cost efficiency very, very low. So make sure you are optimizing cost by minimizing token usage, and task completion rate must be very, very interesting to look at. So these are how you interpret telemetry, and this is the workflow for optimizing the system. The testing mindset. So as an architect, you should also have testing mindset, because testing will help you determine whether the agent is reliable or whether the agent will perform or not. So if you have not tested, then you will know that, okay, the system is not even reliable, or may not perform in the first place. So agents should be tested before they are rolled out to the users. Agents should be tested before they are deployed, and that is why we have stages: development, staging, and production. So you developer deploy at the development stage, then at the staging you test, and then production you deploy to end users and they start using it. And these are the architecture terms that you should understand here. Probabilistic output. Okay, so the probability of success should be very high. Continuous validation. So continuous validation is very, very important. Always validate, follow the feedback loop that we have discussed. Safety. So test agent safety. Is it safe? Is the access to the database safe? Is he operating within the boundary, within the guardrail? Is he obeying the company policy? Is Microsoft Defender for Cloud or Microsoft Purview being applied? Then reliability, is it reliable, is it meeting the need of the user, is it generating ROI, what is the total cost of ownership, and are people adopting it? Then user experience, the entire user experience is determined from secure adoption, how people adopt the agentic AI system. So why is AI testing different from traditional software application testing? So, in traditional software, you map inputs to deterministic logic and to outputs. So you have the inputs. For example, if you build a machine learning model, you have the data that you are training, okay, and then you apply your training algorithm, and then you generate the output. So what you put into the system and the logic or the algorithm you apply will determine your output. So that is in traditional software. But in AI system map AI systems map inputs to model to probabilistic outputs. Okay, so AI system will always map your inputs to model, because or in AI system you have the brain of the model. Okay, so you are not just combining codes to anything. No, so you have the brain just like you have in human being with head and brain in the head. You have brain of an agentic AI. So agentic AI system will always map the prompt that it has to the model that it is built on, and then to probabilistic outputs. So remember, it is this model that are probabilistic and their output is still probabilistic. So even though the input that you have in your agent is deterministic, because the model is probabilistic in nature, your output is still probabilistic. That's why hallucination can come in. Okay, and that's why you still have to measure groundedness, correctness, accuracy, and all that, because LLM model are probabilistic model in nature. Then so output can vary. So the output does not is not deterministic, because input is deterministic, because you are passing a deterministic input through a probabilistic model, and then the output will still be probabilistic. So AI require continuous validation of agent, prompt model, workflows, knowledge sources, safety, and business outcome. So you can see the reason. So you cannot say a probabilistic output will always be reliable. No, it will not always be reliable, because the model, can start hallucinating. The model the model that has been trained, you don't know whether they have been trained on old data. So they can start hallucinating, they can start making mistakes, generating error, and deviating. So that is why you also, because you cannot change the base model, you cannot change the algorithm or the data that is used to train the base model. What you should focus on improving is your agentic AI system. So focus on improving the AI agents themselves, not the base model. You can, if base model is not performing better, then maybe you are using small language where you are supposed to use maybe you are using a small language model where you are supposed to use a large language model. So you should look at the complexity of the task. If it is complex, use large language model. If it is simple, then use small language model. So AI requires continuous validation of agents, prompts, models, workflow, knowledge sources, safety, and business outcomes. Very, very important. Very, very important. So agent testing, agent monitoring, and operationalization is more complex compared to deterministic or traditional software models. So core dimensions that you should be looking at in testing accuracy, performance, reliability, safety, and user experience. These are core dimensions that you should focus on in testing. So whenever you are testing, have the accuracy of the output of the model in mind, have the performance of the whole system in mind. Make sure you determine performance and the percentage accuracy to measure performance. Make sure you determine the reliability. Okay, how reliable is the agent even when it is subject to heavy work. Then how safe is the agent using guardrail and compliance, Microsoft Purview, Microsoft Defender, and collecting telemetry log from Azure Monitor and user experience. So are users or business owner adopting the agent and using it securely? So all these are testing dimension that you should have in mind, as an architect. All right, so agent testing. So we just discussed testing mindset. What should be your mindset as an architect? Now, agent testing. What are the steps of testing agent, and then what are the outputs that you should determine, or that you should collect, or that you should look at from this test? So agent testing framework and their outputs. So we'll look at them in steps, and then we'll determine the output. The first one is define objective. Always define the objective of your testing. Are you testing for reliability? Are you testing for performance? Are you testing for latency or accuracy? Are you testing for user adoption or user experience, etc., as we have designed in the, as we have discussed in the testing mindset? So here, what your design output here should be business outcome. Okay, under defined objective, determine business outcome, expected behavior, compliance, and performance goals. This should be your output here. Then another design is the step 2 is create test plan. When you define objective, then you create test plan. So your output here should be scope, okay, test data, roles, validators, success criteria. So when you create a test plan, make sure the output of the test plan focuses on scope, test data, rules, validator, and success criteria. Step 3, scenario testing. So when you create a test plan, then you start scenario testing. Scenario testing is picking picking from the plan that you have created. Maybe first, number 1, you want to test for performance. Then what should be your output in testing for performance? So scenario testing, your output design should be real workflows, multi-turn conversation, ambiguous inputs. Okay, then performance testing, that's the next step. So what are your design output in performance testing? What are your expected output, your expected information to show whether your performance testing is successful or not? So you should look at load testing here, perform load testing, perform concurrent users testing. So when multiple user uses the agent at the same time, does it perform, and how does it perform? Test for long conversation and test for response time. Then safety testing. So in safety testing, you are determining how safe is the agent when it has access to knowledge base, when it interacts with the complaint data, how safe it is. So here you should focus on data loss prevention, control, access control, restricted actions that you have defined, that you have set guardrail for, that the agent should never perform, or where it should escalate to human in the loop. Then we have prompt injection attempts. All this should be your design in safety testing. Then usability testing. So this is user acceptance and UI testing. So here your design output or focus should be ease of use. Is it easy for users or business owners to use? Is it clear? Is the front end clear? Is the UI clear? Are the user or business owner satisfied? What is the adoption friction rate? So all these are what you should look at in agent testing, and these are the steps and the design outputs that will help you to achieve this goal. So we are done with this function. Thank you for listening. If you are just joining us, please kindly like and subscribe and share to encourage your girl and to help us to or continue to do more videos like this. Thank you.